G'day everybody, my name's Tim Koopmans, and as you can probably tell from my accent, I am Australian. I'm from a town called Cockatoo, which is in Victoria in Australia, down the south of Australia. And when I went to Vienna recently and visited my colleagues, the other fellow PMs, they told me that on social media there was a rumour circulating that Australia doesn't actually exist, that we're actually just a bunch of paid actors going around, that we didn't really settle in 1788 or whatever it was. But I am here to tell you that we do exist. Australia is a real country. We've got another Australian here, my co-founder of Flood, Ivan. We're all pretty tall. Is there any other Australians here? Yeah? Oh, you're not? Oh, well, yeah, I suppose. Sort of sound like an Australian. But yeah, anyway, just to prove that Australia does exist, I took some photos before I came over here, just to show you what Australia is about. We've got lots of beautiful country. Like here's me at my property down in Cockatoo. I'm looking at that, we've got lots of hills. It's not all desert, and there is some greenery and lots of water and stuff like that. Here's another one of me with a nice sunset, as you can see there. We've got lots of sunsets. They're beautiful down there. Yeah, here's me at the beach. And yeah, there's lots of beautiful beaches in Australia, of course. Yeah, where else did I go? I think, hang on. Oh, well, I'm stuck at the beach. That's never a bad place to be. Oh, I went too far. Hang on. We'll go back and steal all my punchlines. Can I go back to the beach? Do a little tap dance. Let's try that again. All right, I just ruined my own joke there. But that's, that's cool. That happens. Is my remote control dead or something? Have to wave. There we go. At the beach. At the snow. At the snow. I don't know. I'll just try and get to a slide that does advance. It's I don't know. Okay. Hang on, just a second. Yeah, I didn't load test my slide deck. Yeah. Okay, there's me at the snow. Anyway, the joke was going to go, do you know what we don't have a lot of in Australia? Can anyone guess now that you've seen the slides? Well, no, we've actually got more snow than the Swiss Alps. So I don't know if you knew that. You can fact check me later. But do you know what we don't have a lot of? Well, we don't have a lot of bandwidth in Australia. In fact, this is the net speed test from my home. It's a blazing 3.4 megabits per second down. I've got 0.26 megabits per second up, and an awesome 440 milliseconds gaming speed. Okay, ping or latency. So that's what I have to deal with on a day-to-day basis. Actually, Australia is a really bad place to run a distributed load testing company from. We're ranked 50 in the world, so it's really like living in the slow lane in Australia. So I think it's kind of ironic that both the founders of a load testing company come from such a country with these sort of speeds. And just some more facts, like cockatoo, which is a bird, by the way, not what you're thinking. It's an angry parrot, and it's where I live. It's 7,856 miles to get here. It took me 14 hours and 15 minutes by air. Theoretically, it would take 42 milliseconds at the speed of light going through a vacuum, but of course that doesn't exist, or not on Earth anyway. and it's 59 milliseconds to travel over a piece of optic fiber. So the minimum time it's going to take is about 59 milliseconds. And if you look at round trip time, the best possible case is probably going to be about 118 milliseconds to every request that comes over here and looks at websites or whatever we want to look at in San Francisco. So for me, this is the reality. I don't get 118 milliseconds. I get 440 milliseconds. This is my 26 pair cable up the road that I share with my neighbor. It's often full of water and snails and poisonous spiders. So that's about the best that I can do where I live. This is actually where Ivan lives. I think he measures in seconds. So that's kind of like what we have to deal with. And you might be wondering why I'm talking about all this stuff and what's it got to do with continuous load testing. It's, if you look at it from, look at a website, Wolfgang, almost forgot his name, the CEO, well no, the CSO. He was talking about all the traffic that happens at the browser level, the requests that are made. This is a look at all the traffic that happens at, say, the protocol level. This is like a TCP dump. So each one of these is like little packets of information going back and forth, just looking at a typical website. There's lots and lots of conversations, TCP conversations, and all of those suffer from really high ping. It really sucks. So like if you're going to build a distributed load testing platform, you want to make sure that your website loads pretty quickly. So we take pride in doing that. We put a lot of effort into making sure that even over a simulated 3G network, that the Flood.io website loads nice and quickly. If you look at the trycentus.com website over the same simulated 3G network, like Australia, yeah, this isn't you guys, by the way. This is, this is in the script, and we'll keep waiting for that. So this is actually what happens when the marketing team get hold of your website. That's my first tip today. Don't let marketing control your content website. And we should be there any second now. It's awful, isn't it? It's response time. It sucks waiting for this. Oh, where did it go? There we go. So that's what it looks like loading our company website from Australia. It's pretty horrible. If you look at that, the web page test score, there's a couple of big red Fs there. Once again, sorry Wayne, he's not here. Cynthia, you can take the blame for this. But yeah, we definitely need to fix that up because it's terrible looking at this sort of thing over the wire. And I guess what I'm trying to say in a roundabout way, and on the theme of continuous load testing, is I've always said that performance is everyone's responsibility. But as soon as you say something is everyone's responsibility, that normally means that it's nobody's responsibility because no one wants to do that job. And often the people who's doing load testing, by the way? Anyone doing load testing? Yeah, often you're like this person here. It's like you're shoveling a lot of, crap. What do we say here in America? You're shoveling a lot of that, and it's a tough job. And so, performance is something that affects everyone, and it kind of becomes everyone's responsibility, but no one's doing anything about it. And the thing about performance is that everyone cares about performance. So I was just showing you response time before, and this is just like looking at the same site over two different connections, and the one on the right is loading about 5 times as quickly as the one on the left. And everyone has like an intuitive feel for performance. Like when response time sucks. Performance has a whole host of sort of application performance measurements that you're interested in. Things like transaction rate and concurrency, response time, latency, bandwidth, throughput, all of that stuff. People are pretty well versed in terms of what they mean or how that impacts you. But that's not the only dimension that we care about. I mean, there are other dimensions of performance that we should know about. And availability is a really big one because when your systems aren't available, like everybody knows about it. You know what I mean? You can't escape an outage. People will tweet about it. You'll be on the news. Your competition will laugh at you. And it happens to everyone, right? It's happened to us at Flood. We are dealing with some serious scale, but like it's something that you need to factor into your testing. This is what you're trying to avoid. Reliability, it's more complicated than just testing for HTTP 500s, which is in the SAP Fiori demo, by the way. It could be a HTTP 200 and it's returning data that you're not really expecting. Or like in my experience, I did a job at a bank and the cache was actually returning other people's bank balance, for example, which is kind of uncool when when you're a bank. And I had a colleague that was found a race condition in the bar, the what do you call it, the printing machine for blood bags, and it was a race condition, which means that threads are getting confused and it's printing out the wrong labels on blood bags. So that's kind of not cool. That can have like a pretty serious impact. And scalability, like this is just the modern word for capacity or capacity management. Like time is money, right? You need to know, can you meet the demand? Like, can you provision enough infrastructure to meet the demand? Can you scale out to meet unanticipated demand? Can you scale back in? Are you leaving resources out there that are just burning hours? How much is it all costing? Have you got the right sized infrastructure? So these are all the sort of things that we want to test for. But the question is like, how do you test for all this stuff? Like I know everyone's focused on functional test automation, but typically this is in the domain of non-functional test automation, I guess. And I call it load testing. Some people call it performance testing. You'll hear lots of different words for this, but I think load testing is the easiest or the best description of what it is. It just means putting demand on a system and just measuring it for performance. That's the easiest way to describe it. Or it could be availability or scalability or reliability, is stuff that I was talking about. And then when we sort of get into what continuous load testing means, we have to first break down the definition. Continue means to just persist or carry on or resume, and many make the mistake that thinking that this is all it takes to do continuous load testing, right? You just resume a stopped effort, or you just repeat something that you did last quarter or last year, and that's all it takes. Well, that's not right. That's not what continuous load testing is, because the marvelous thing about the English language is if you drop the E and add an OUS, it takes on a slightly different meaning. And continuous actually means to do something without interruption. That's part of an unbroken whole that's progressive in nature. So that's really what continuous means. So I ask you, why do we care so much about continuous load testing? I mean, apart from search engine optimization and being number one in the results, like, why should we care about continuous load testing? Anyone? Anyone? Bueller? No? Okay, I'll give you the answer. It's all about minimizing risk, okay? I've been this guy, on the change advisory board, or doing a load test just before we reach production, and giving the go, no-go decision about my, whether we're fit to go to production. So we've all been this guy. It's in slow-mo, which is even better. Only in America, right? And yeah, what? How much CPU is on this laptop? Yeah, and this is me just bailing out at the last moment. There we go. He's out of there. So, what am I trying to show with this? Load testing is about reducing risk. That's what it is. It's a risk mitigation strategy. It's about identifying risk. It's about putting in controls around risk so that you can avoid this stuff happening in production. That's the key thing about what, the outcome of load testing. It's not about pass-fail, strangely enough. And I think a lot of people look for little happy dashboards with lots of green lights to say, everything's good and everything's bad. It's not really about that. It's about managing risk. Because application risk often transposes into much bigger business risk, and business risk normally means you're losing customers or you're losing money, or both. And so you have to be truthful with yourself. When you're thinking about your load test effort, you have to say, well, how many decisions are you making from load testing? Is it measured like in the number of decisions that you make per year? That's not going to be great. You really want to kind of get down to making lots of decisions all the time, like decisions per week, for example, because only then you get to sort of exercise all the different parts of the decision tree and hopefully get to a point where you can actually ship software that your customers love. I mean, that's what we're trying to do. So on the topic of like, when should we do continuous load testing, hands up if you think we should shift left. Oh, okay. Is that because it's on our banner? Yeah. What about shifting right? Anyone put their hands up for shifting right? None. Okay. Who knows what I'm talking about? Shifting left and shifting right. Everyone know? Yeah. Okay. Good. Well, I actually think there's no fixed direction that you should shift load testing, because it kind of implies, a single direction. It should be something that you do all the time. So looking at the way we do it with Flood, we talk about performance very early in the requirements phase. I'm not talking about detailed requirements. I'm talking about just, specking out stories to features. We'll be having a performance element to them. We obviously look at things that are happening in production. We want to make sure that big spikes don't happen again. We want to try and sort of replicate those maybe in a test environment so that we can test for it and prevent them from happening again. We definitely do stuff around earlier back in the code so that we can attribute a change in actual source code back to a performance regression, for example. And the only way you can do that is to test all the time, so you can minimize the delta in terms of what you're looking at. And of course, you're going to have some form of load testing that's probably linked to your continuous integration or your CD sort of pipeline. So we're doing load testing all the time. And we saw this little Infinity logo before. It was, I think it was in, was it Sandeep's presentation? And it's on our web page. It kind of implies like, dev is on the left-hand side, and it's like the DevOps logo, and we've sort of hijacked it and put continuous testing in the middle. But that kind of, once again, that it implies that continuous testing is just something that happens in the middle. I like this diagram better from Dan Ashby. I think this guy, this is like a couple years old now, but I think he's right on the money. We definitely want to do testing around planning. We want to, when we branch and merge code, we definitely want to test. When we build it, we most certainly want to do some load testing as we release it. Yeah, absolutely. We want to see how it performs in production. We probably want to do some sanity stuff around the deployment. And as we continue to operate and monitor in production, we want to be doing testing there as well. So continuous testing is about doing continuous testing. It's not about just like a one-off activity. So that's the why and the whens, but I guess now I want to ask you why not, like why aren't you doing load testing? Who's not doing load testing? You can answer that one. Is everyone doing load testing? One. So everyone else is not doing load testing. Okay, I'll tell you what the 4 biggest blockers you'll probably identify with these, and I'll use SpaceX program as the sort of analogy, and we might struggle with the animated GIFs here, but we'll see how we go. Okay, here we go. 1, 2, 3, go. All right, so creation is the first big issue with load testing. You have to actually build a rocket ship, it feels like. You need like space engineers to try and get something going, and then you do your first script and it doesn't do anything. It's just like it blows up spectacularly, and you need these guys with propellers on their head to try and get anything done. So this is like the first massive blocker to getting started with load testing. We hear that from our customers all the time, like, oh, we want to load test, but we have no idea how to get started. So creation is a big, big blocker. The next big thing is reusability, right? Let's see what's happening here. I've got a blank screen. No, I just think it's going to take its time. Anyway, if you can imagine a rocket that's blowing up, you've seen the SpaceX program where they try to land the rocket. Reusability is a really big issue, right? Because once you've built a script, and that's cool, and you've done that for that first release cycle, then the next sprint or the next release, whatever you try and do, the load testing again, and of course everything has changed and nothing is working anymore. It's like my slide deck basically. So you have to start from scratch again and build it all over again, and it just adds a huge burden to the maintenance overhead for load testing. The next big issue, and I've given up on the slides, is that there's this is pretty cool because the rocket ran out of propellant, okay, and so it tried to take off and it falls back down. Good visuals here, I can just talk to it, but like test data, it's really hard to provision for. Like it's hard enough for functional automation. Imagine doing it when you need 20,000 users to sign in with unique credentials, and they all need different transaction histories and blah blah blah. Like, test data is a really huge blocker to load testing or to continuous load testing. And the last one, this is where the rocket is kind of like sliding around. It's on the little flatbed ship thing that they float out to sea, and it's falling over in the weather. Environment, you need a test environment big enough to sort of do the testing itself, the load testing. You can't just run it on your MacBook or on the presentation machines at the back, obviously. You need significant infrastructure to be able to actually generate the load in the first place and also receive that load as well. So test environments can be a really big blocker for continuous load testing. And then once again, on a blank slide, this is hilarious. When the rockets land and you've got all your telemetry and you've got enough fuel, it feels great. It feels really good, and it feels like a wise investment in in that really expensive $1,500 a day resource that you've paid for start as a 3-month contract and has turned into an 18-month contract. But it feels great, and then you go through and you get to the next release and you've got to do it all over again. So these are all the big problems with load testing. So when I joined Tricentis, we were like, well, how can we make this better? Like, how can we improve load testing? Because we always had this holistic goal with Flood to make a load testing platform that was available for everyone. We just didn't want it to be a tool, yet another engineering tool that's for the propeller heads over in the corner. And so we've got this big Austrian mountain range, which is, somewhere in Austria. And this is symbolizing Tosca, It's a nice piece, a big monolithic piece of software shrink wrap that gets quarterly released. And I had to think about, well, how do we actually do this with Flood? Like, what are we going to do with Flood? So we couldn't move the mountain, so we moved our stuff to Tosca, and that's how Tosca Flood was born. We used Docker containers. We did a whole bunch of really impressive, like pretty sort of leading edge stuff. I won't bore you with the technical detail, but we got it all stitched up together, and it looks pretty cool. Are you interested in seeing how it actually works? Yeah. Okay. Because we really have made it easy, and I don't know if this next slide will work, but we'll just see. Here we go. Okay. So to make it work, this is in Tosca. You just go to an execution list. You create a new load stream, we call it. And we take an existing test case that you've already done in a functional scenario and just drag it up. So that's it. There's nothing else. That's it. That's it. So that's how you can do load testing now in Tosca. There's a bit more to it. There's a little UI that's not going to show up. You have to pay for that. But that's terrible. But it's amazing, though. You should go check it out. Come down to the booth and see anyone from the Flood booth, and we'll show it to you. But it's a very simple UI to set things like the number of users that you want to simulate, what regions you want it from. I should have done this on a Mac. And I can't think of the other things. But yeah, just trust me, it's there. Okay. Oh, it's getting confused again. What are we up to? Oh, okay. Yeah, this is how you run a load test. That's it. Sorry, we kind of missed it. We'll wait for it again. This is how you run a load test. You select the load stream. There's a stream configuration really briefly, and you hit run. So we take care of all the provisioning of the load test infrastructure. We start it all up for you. You don't have to worry about all that. We do all that on the cloud. And then the good thing is, boom. This is just a picture. I don't know. Anyway. It's classic. So anyway, the good thing is there's a really nice dashboard that you can look at. And once again, you can come down to the booth and check that out. It's really good to see. So Wolfgang mentioned blues. We do have a really strong focus on blues, as we call them, browser level users. So that's using real browsers. We use Google Chrome, and we spin up tons of them out in the cloud. And that's how we generate the load. We trade in a lot of the complexity that you're used to doing at the protocol level if you've been doing load testing. So it's a really nice substitute. But in some cases, it does make sense to still use like APIs or what we call protocol level users. So you can still test at the protocol level user, of course. And you can still test with all the tools that we traditionally support, which are JMeter, Gatling, and Selenium, for example. The key takeaway, provided it comes up, is, I don't know, the key takeaway is maximize reuse. That's what I want you to go away with today, aside from the missing slides. I want you to leave today thinking about load testing as being able to reuse all of your functional test automation assets. That's all I want you to remember. That's how you get started with load testing. There we go. It's all over the shop. There's my symbol. Yeah. I'm going to give up on the slide deck. I think that's about all I had to say. How am I going for time after all that? What time is it? 5 more. All right. Okay, it's coming. We can wait for it. So yeah, I mentioned, you remember I was talking about, let me get my train of thought back. So what we've really solved is the creation issue. We've definitely solved for that. We've solved for the reusability issue because we can just reuse the functional test automation assets. For the test data thing, that's still a pretty hard nut to crack. Have you heard of the test data service, which is like a better TDM? That's coming out in Tosca. It's already out in Tosca, actually. So it's a lightweight in-memory data store. So we'll be using that for the functional test cases. They can refer to those data. We'll respect that syntax, of course, from a load test. So you'll be able to have, for example, if you wanted lots of different user logins or whatever sort of static data you need to drive the test, that will be available to you from test data or TDS. Yeah, cool. And another good thing that we'll be doing more with is orchestrated service virtualization. So this is a really nice pattern to sort of get into when you're thinking about, like, if you've got more complicated environments, you have, say, mainframe sitting downstream or third-party services that you need to stub out and you want to start doing more of a component view of performance, then this is a really good solution to look at. So this is also part of the continuous testing platform that's with Tosca. I guess what I'm trying to say, like if I'm going to close down the presentation properly now that I've got my slides back, stop building rockets. Like you don't need to keep building rocket ships to do your load testing. Try for something more simple. Maybe try for a lot of browsers, for example. That can reduce the complexity tenfold. I just pulled that number, but it can really reduce the complexity a lot, especially if you're testing something like SAP Fiori or other package applications like Salesforce. Maybe you want to sort of supplement it with a bit of left click. Yeah, anyway, maybe you want to supplement it with API-based test cases. Yeah, that'll do. and I guess I'm really disjointed here, but closing message. Tosca Flood, we're not trying to make you performance engineers. We're not going to pretend that just now because you can drag functional test cases up into an execution list that you're suddenly a performance engineer that can resolve database issues and cache invalidations and race conditions and all that sort of stuff. What we can do, though, with this is get you talking about performance and get you talking about availability and scalability and reliability. You can start having that conversation with the right people. And I think it was Anders that said this morning in the great debate where he said, one team, one fight. That's exactly what we're trying to go for. We want a tool. We don't want the tool to be excluding people. So it's only a bunch of, those three people over there that know how to drive it. So this is all about getting the conversation started. Thank you. Thank you, thank you, thank you, and thank you. Any questions? We need the mic, I think. Yeah.
Yeah, the missing videos. Now they want to see the missing videos. What was that? You get this?
I was just wondering if the Tosca Flood and the Tosca virtualization, they work together, right? So like, let's say I have a UI and then the API level. I just want to turn off the API and just measure the load testing only for the UI. So that would work, right?
Yeah, so there's a differentiation between API and browser-based test cases in Tosca, as you probably know. Like, a browser is driving a real browser, and API is working at the protocol level. Yeah. You're saying, can you do the
So I only want to measure the low performance of the UI. So
yeah.
I want to turn off the API layer.
Yeah.
So the virtualization would do this job with Flood, right?
Yeah, it's another level of abstraction above, and I guess the best way to describe that is when you're testing things at the protocol level, you're kind of interested in individual discrete requests and the response time, and you might group them. You might try and group them together in like a transaction that represents a business transaction, but it's kind of you're kind of averaging and trying to figure it out. The beauty about testing at the UI is you're testing like the user experience. So if you can imagine, like, protocol level is just stuff across the wire, but in the browser, it's the stuff across the wire. It's the passing of the JavaScript, the execution of the JavaScript. It's the rendering. It's the idle time, and it's there's a whole bunch of other stuff. So you're getting a much more realistic measurement as the user would see it. Yeah. Does that answer the question? Yeah. Yeah.
Great. Next question here.
So as I understand, flood is, the load is generated from the cloud, and it'll, hit your applications. As a customer that has some on-prem systems that we don't want to expose to the internet, are there any options for us to use flood to exercise that?
Yeah, it's a really common question. So the issue is, like, if you have applications that sit behind a firewall, there are options. Like eBay is a good example for us. For a customer, we provide them with static IPs, for example. We give them about 400 off the top of my head, and they just ingress those static IPs through their firewall to let them into their test or QA environments. So that's a pretty common pattern that our customers are using. If you're already on the cloud, we can of course do things like private subnets within virtual private cloud, so we can support that for AWS and Azure. If you're completely firewalled off from the internet and you have no real chance of ever exposing stuff, this is not going to be a good solution for you, because as soon as we put stuff on premise, even though it's technically possible, you sort of lose the economy of scale that you get from the cloud. So we're talking about starting up lots of machines to generate the load. I'm certainly not going to recommend doing that same browser level approach by provisioning your own bare metal. It's just not cost effective when you compare it to a cloud solution.
Hi, let's say if I'm running load testing as part of my pipeline, does Tosca takes care of the benchmarking for each and every execution and then tells me what's the breaking point and threshold?
Not really. I mean, I think on the roadmap there will be more of, like, as we move more of Tosca to the cloud itself, it will make sense to sort of start sharing some of the analytic data. But if you think about load testing in 3 parts, so creation, execution, and analysis, Tosca is taking care of the creation side of things. So the creation and reuse maintenance of test scripts, let's say, it takes care of that. But the execution and analysis is definitely all on the Flood platform. So you will still go to Flood, you'll use the browser to look at historical results, for example. And I think you mentioned, like, if you're launching it from CI as well. Yeah, so there's different ways to skin that cat, basically. I mean, a lot of our customers are already using our API. We have an open API, a RESTful API, that they can just use from Jenkins or whatever build tool they want to launch and programmatically control floods. And in a similar fashion, you can do that with Tosca as well. So it really depends on your entry point to starting the test and what the options there are. Yeah.
At least, shall we leverage the Tosca report, like for each load test execution, and then see like what's the difference between each?
Yeah, it's going to be a better experience in the short to medium term in Flood, because that's something that we change all the time. I didn't get to show you the screenshot, but you're welcome to come and have a look. But we've focused very heavily on analytics and making it easier for you to compare results, for example. Tosca right now, has traditionally been a functional test automation tool, and just saying like pass-fail or the number of test cases run isn't really meaningful in a load testing context. You need more information from load testing, so yeah.